League of Legends, a multiplayer online battle arena game, aka MOBA, has become the most popular games in the past few years. The goal of the game is to destroy enemy teams' nexus. In order to win this game, it is important to get more golds than the enemy team, so that players can buy higher level items to win the team fights. But what are some variables that affect the gold difference between two teams?
Hi everyone, today we will present the analysis of the goal difference between two teams in the game League of Legends. My name is Hongxiang.
I'm Junxi.
I'm Yuning.
This is an overview for our project. Data preprocess. There are more than 24,000 matches and combination of categorical and continuous variables. Some matches in the data have values such as 2 destroyed base turrets, but there is only 1 base turret that can be destroyed. These typos can harm the validity of the model, and therefore we will remove them. Then we fit the full model. The constant variance and normality assumption is satisfied. Outliers and leverage points will be discussed later. However, we realize that these 4 variables are all 0 for all the matches. Yes, Yumi, this will cause problems in our model calculation, so we have to remove them.
Now I'm going to talk about the multicollinearity in the predictors. To deal with multicollinearity, we use color maps on correlations and variance inflation factors. VIF is more general than a color map on correlation since it can indicate if a predictor is a linear combination of the others. Generally, predictors with VIF larger than 5 have serious collinearity problems, which are shown here. We first removed experience difference with largest VIF. Each time we remove a predictor, VIF is calculated again. After deleting the experience difference, the VIF of champions level difference became smaller than 5. There is a formula for calculating the kills, assists, and death ratio, so we add a KDA predictor, then game duration is deleted as well. Now we check the color map on correlations. As shown in the plot, there is a high correlation between champions level difference and experience difference, and between kills and assists, which are already solved. There is also a high correlation between numbers of Rift heroes killed and lost, so we keep the first one. After solving the problem with multicollinearity, we fit the linear model again. It satisfies the assumption of residual normality and constant variance. However, there are still some bad head leverage points we need to consider.
Now it's time for outlier removal. There are 44 predictors and 1 intercept, so high leverage cutoff is about 0.0053. From the plot, we see that there exists bad high leverage points such as the ones in the red circle. After removal, we see no more outliers in the regions. Variable selection. At this step, we still have 44 predictors left. Here, we use forward selection with the base information criterion. From the plot, we see that BIC is the smallest when the number of predictors is 39. Here are 5 predictors that are selected out. From the summary table, we see that all the predictors have a low p-value, and therefore they are all significant by this point. Also, champion level difference is selected when only 1 predictor is allowed in the model, which means that it's the most significant predictor. Model evaluation. Finally, we fit the final model on 70% of the randomly selected data, and then predict the goal difference of the last 30% of the data. Then we plot the predicted goal difference against the actual one. The model achieves a R-square of about 0.95. Conclusion. The final model has a slightly lower adjusted R-square and less predictors used. But the final model addresses the problem of multicollinearity and outliers. Here are the 15 predictors removed from the list. Also, we convert the kill, death, assist to the KDA ratio. The most significant predictor is the champion level difference, which makes sense since a high champion level difference expands the team's advantage. Thank you for listening.